accurate delivery is a very important requirement. I'm just showing you a video of workstation which you might be using. I'm not sure. So right now I'm delivering 500 ml flow, okay, and the tidal volume which was delivered was 340 ml. Okay, now I'm trying to increase the flow. Okay, I'm increasing it to the 5 liter total. Okay, see the jump in tidal volume. Can you see this? I have not done anything there. I have not done. I have just increased the flow, and the tidal volume delivery has reached 470 ml. Now imagine this situation in a pediatric patient. At the end of anesthesia, you increase the flow to flush out the anesthesia, or what you call anesthetic agent, and then tidal volume jumps in a pediatric patient. Now, why this is happening? Okay, to understand why this is happening and what different anesthesia machines are giving us technology or the system inside to prevent this is what we are going to learn next. Okay, so to do that, we'll have to understand the basic circuit design. I think Apex has also showed you this particular diagram. So that's a canister. This is ventilator, bellows ventilator. This is flow meter. This is APL valve here. Okay. When patient expires, okay, the expired gas passes through the expiratory unidirectional valve. That time inspiratory unidirectional valve closes. Okay. Same time when the flow is a constant flow. So flow is flowing through the soda lime canister and goes to the reservoir bag when patient expires. Okay. Now when either patient breathes or we squeeze the bag, the flow reverses. Now this expiratory unidirectional valve will stop. Okay. And the flow will pass through canister. Simultaneously, same time the flow is also flowing through the fresh gas flow is also flowing. It will pass through the inspiratory unidirectional valve and deliver to the patient. Okay, this is a basic circuit and the flow which is there in all the machines. If we switch over to the ventilator, okay, the bag cuts off, bag is no longer in use, and the ventilator works. Now let us understand. If you have set tidal volume at say 500 ml, okay, so I have set tidal volume at 500 ml. So 500 ml for 500 ml of air or anesthetic gas, the bellows squeezes. Okay, at that time if your flow is 2 liter, okay, so 2 liter flow is also flowing, and here in this line they are mixing the air which is coming from the bellows and the fresh gas flow. So what will we get? If there is a 2 liter flow, in that one breath we will get somewhere around 570 ml, because ventilator gas and fresh gas flow which is flowing continuously is mixing. Okay, 570 ml. Suppose if we increase it to 4 liter, what will happen? This 500 will continue. Okay, and instead of 70 ml, 140 ml will be added. So what you get is 640 ml. Now this is something which is happening, which was happening in that particular video which I showed. When I increase the flow, the extra fresh gas flow also mixes into the inspiratory line, while the ventilator delivers the fixed tidal volume which you have set. So this is the problem, and it was present in all earlier workstations also. Okay. Now how workstations trying to prevent this? So the problem is here, mixing. Problem is mixing. So the Dräger company has developed a valve here. They put a valve. So their design slightly look different. This is a piston, and this valve is called the decoupled valve. Okay. So decoupled valve is there in piston-based anesthesia workstations. So now what will happen? When you are squeezing, the pistons are pushed, okay, for 500 ml, this creates positive pressure here. So this valve will open and this valve will be closed, the decoupled valve. So what patient will get? Only which is delivered by the piston, because fresh gas flow is not mixing here in inspiration. Okay, where fresh gas flow will go? It will go to the bag. So have you ever observed a different behavior of your reservoir bag in Dräger machine? It will inflate in inspiration. You would like it to get squeezed, okay, but it behaves differently. Every time when the ventilator goes, when the ventilator works, it gives inspiration, bag will get expanded. That is opposite to our conventional thinking. Okay. The reason is this decoupled valve. When the piston pulls back, okay, it creates negative pressure here. So this is getting closed, and from the bag and from the fresh gas flow, the oxygen, the total flow will come to the piston. So what you will see in expiration, bag getting squeezed. Okay, so this is a patented technology. Here there is no fresh gas mixing in inspiratory line during inspiration. Simple. It does not go to the ventilator part or the piston part. Now this cannot be used by the other. So what others have done? So what they have done, 500, 200, 4 liter, 640. So what they have done, they have put a sensor in the inspiratory line. Now this sensor will start sensing that, okay, extra 140 ml is given because we have set 500. Extra 140 is given. So next time, the ventilator will squeeze less. So this bellow will squeeze less if you increase the flow. Okay, so bellows machine will squeeze less. Now it will squeeze for 360. So then the resultant tidal volume is final 500 ml. So this is called the fresh gas compensation. So this is a fresh gas compensation technology which is with the help of the inspiratory flow sensor is delivered. The only problem is that it is happening in the next breath. So we'll get some amount of higher flow in one particular breath, and then gradually the machine will start reducing the squeezing. So it is called the relative compensation. You do get slightly increased tidal volume delivery in at least one breath. Earlier it used to take long time. The computers and softwares were not very good. So it used to take 6 breaths to come back to the normal. Now these softwares are better, so it comes back to the normal in next 1 or 2 breaths, but it is not in same breath. While this particular technology, fresh gas decoupling, where there is no mixing in inspiration, so it is called absolute compensation. Okay, so we have two technology, fresh gas decoupling and fresh gas compensation. Some of newer machines has multiple sensors, and they really sense every very short time frame. So they sense every 40 millisecond. Okay. So within 1 second, which is the inspiratory time, it does measure the tidal volume and change the dynamics. So this would be slightly better than the other technology where the sensing would be slightly less effective. Thank you.